Welcome back one more time, and this was the last series that we are continuing. So, in this one, we will be finishing this particular series. I'll try my best to complete it as fast as possible within this particular video only. So, we have stopped till that particular point where we are talking about the control cables, okay, and then we were also talking about the components that are basically used in a control cable mechanism or in a mechanical system of control cables, where we have seen what is a fair lead. It is to guide the cable through a certain portion of the aircraft, okay, and there is a split fair lead also, you can see. Then there are retainer rings in the diagrams, you can see, which actually retains the particular like it will be retaining the air seal that is present. Now, why is the air seal that is required, and why are all these things basically required? So we will just read one by one in the paragraphs, and I'll explain it to you. I think that would be better. Okay, so pulleys we talked about. Pulley may be used for changing the direction, and fair leads are also used to guide control cables along their length. And the material can be of plastic or some other material. Okay, definitely not metal, because metal will actually, you know, if it touches with the control cable, which is also metallic, so what will happen, there will be a lot of erosions, okay, a lot of wear outs will take place. So definitely we will not use metallic things. We use a type of a material which is normally not metallic. Even if it is metallic, we make sure that it is not as hard as the control cable, so that it does not have any impact on the control cable, okay. I mean, the fair lead or whatever is there, that should wear out, but not the control cable. Then the cables that extend from pressurized portions of the aircraft to unpressurized portion areas use seals to prevent loss of cabin pressure. Now, why this is required? Because you see, when there is a pressurized portion in the aircraft, now you have to pass some control cable from a pressurized section to an unpressurized section. Now, obviously, you need to make a hole through which the through which this control cable will pass. Now, if those control cables, let's say over here they have given, okay, or maybe here you can see actually in a better way, okay. See, let's say this is the pressurized section, this side, okay, and this is the wall. This particular thing is the wall, basically it's like a separation, and over here there is unpressurized section, this side, okay. Now, if something is actually passing through this particular two sections of a fuselage or any aircraft, then there has to be a hole through which, over here, through which this control cable will move, right? So if it moves, then obviously it requires some sort of a tolerance or some sort of a gap through which it can actually move freely. Now that gap cannot be too much. If it is too much, then the pressurized section, all the airs will be leaking towards the unpressurized section, right? So we will not be able to maintain the pressure inside. There will be leakage. So in order to avoid this leakage, what we do is, see, we have put an air seal over here. Okay, it is a cutaway view of this air seal, which means the air seal is like this, okay, through which the control cable is passing. Okay, now this air seal is given so that it will allow the control cable to move. Also, it will not allow any pressurized air to go to the unpressurized section. So your pressurization leakage problem is also solved, and at the same time your mechanical movement, the movement that you actually require for the control cables, that can also take place. Okay. Okay. Over here we have got guard pin. Now, what is a guard pin? Guard pin is basically, it is a limitation. Like, let's say there are a number of cables. Like over here you can see 4 cables are passing side by side, right, from this side to that side, all total. Now, if we don't put any guard pin in certain areas, then what happens is these cables can go up or it can go down. Like, they can actually make oscillations like this, okay, when they are pulled, or when they are being pulled. So this guard pins is basically, it is sort of a guard. By the name we can understand it is sort of a guard that is not allowing the control cable to go above this point. Okay, fine. Okay, Turnbuckles we already talked about in the last video. The turnbuckles are the ones which are used to adjust the cable tension from both the sides. We will adjust these two parts, this part and this part. When you screw, the tension will be created more. When you loosen them, then what will happen? The pull will be less, the tension will be less. So these you need to set by the desired AMM procedures that have been given, and aircraft maintenance manual you have to set up this by the help of this gauge. Okay, this is called tensiometer, which sets the tension of a cable. Fine, you see they have put the cable through this. There are 2 points which are called as anvil, and then the pressure, or rather not pressure, I should say the stress that is there. Okay, that stress is basically shown in this gauge. The stress, the tensile stress that is created in the cables, that is basically shown in this particular gauge. So this is called tensiometer. So over here there is a chart you can see. Okay, as per the diameter they have given some tensions in the list, and according to that you can set your tensions. Now this is just a random chart, but obviously you have to make sure that you use your AMM procedures for this. Fine. Okay, then they are saying that an end with the right handed thread and the opposite end with the left handed thread. Okay, now turnbuckles, one thing to know, that turnbuckles will have one side right handed thread and the other side left handed thread. Okay, which means that if one side rotates clockwise, right, then the other side will not rotate clockwise, it will rotate anti-clockwise in order to tighten it. Okay, so both will not be rotating at the same direction, they will be rotating in different direction, so that the screwing action can take place and the pull is created properly. Okay, and then we can set the tension. And what about locking this particular device? See, these are the locking wires or the locking mechanisms through which you can actually lock them, so that they do not move during any adverse situation that is created inside the aircraft due to some external load or maybe internal loads or anything. Okay, so that the tension of the control cables do not go loosen or do not decrease. Fine. So that is the reason wherever you have to set them, you have set it, after that you have to lock them. Fine. So turnbuckles are definitely locked in order to maintain that particular tension in the cables. Now cable tension regulators to maintain proper cable tension throughout the range of conditions, these I have already said. Push pull tubes are there, push pull rods. See, cable can be only used to pull, not push, right? It can only take tensile loads, not compressive loads. You cannot push anything through a cable, you can only pull something through a cable by the help of a cable. But in push pull rods, these are certain types of rods which are allowed to transmit force or allowed to transmit your effort in any direction. You can push, you can as well as pull. That is the reason these are called as push pull rods, because any rod is a firm thing, it's a solid thing, so we can actually push something with that, we can also pull something with it. Fine. So their ends are having eye bolts like this. See, not eye bolts, rather we should say like eye joints. This looks like an eye over here because at the center there is a hole. Fine. So they are also adjusted. See, they also have got 2 threads on both sides, then they too have nuts on both sides, and as they are a firm static, as they are a solid firm shaft, so they can be used to push something as well as pull something. Fine. Okay, now okay now fine. Okay, so these are the pictures basically that will give you a brief idea about what is happening. See, this is a bell crank. Okay, a bell crank is sort of a thing which is used to change the direction, or rather any offset direction. Like this side it will be pulled, so over here there is a hinge mechanism, there is another hinge mechanism over here. So if this is pulled in this direction, there is the third hinge mechanism over here in middle. So basically this is the bell crank, actually only this much. Okay, and when this is pulled by a push pull rod on this side, then this end will be going this side and this end will be pushed in this way. So this rod will be going and pushing something else, right? So these are just used to transfer the loads in various directions which are not possible by human capability or like may not be possible by us to keep in mind or like to control each and everything so quickly and efficiently. So these are the small things that have been given in the aircraft which are used to control things very efficiently. So there is a series of levers that are able to receive an input signal and deliver an output signal. Bell cranks change the direction of movement, just like pulley also does the same. Input signal may come from a lateral direction. Yeah, I have already told you how it comes. Lateral means it's a sidewise direction from which you are either pulling it or pushing it, and the output motion made in a longitudinal direction or vice versa. I mean, like let's say somebody is pushing something from the lateral side, in some other direction it will be changed. Okay, so it is to change the direction of motion also. What is a jack screw? Jack screw is given over here. This jack screw is very common in modern aircrafts, because we generally have a sort of an actuator mounted over here and a hinge point over here, and we have this Acme thread. These are Acme thread. Okay, this type of threads are called Acme threads. This looks like square threads. This Acme threaded shaft, or rather you can consider this as a big bolt, okay, for your understanding purpose. So this screw or bolt, so which is actually inside this actuator, when this actuator is moved, there is a motor which actually rotates like this. So what happens is that this screw, by the help of that rotating action, it will have a screwing effect, and it will come out like this. It will rotate and it will come out like this slowly. So as one point of the screw is hinged to some flight control surface, okay, so when this screw comes out in this direction, so when this actuator will rotate, this screw will come out in this direction. If it rotates in the opposite direction, okay, this screw will get inside. So it is happening by the help of the screwing actions. So as it is a screwing action, that is the reason it is very slow. Okay, slowly you can change the angle at any given point, fine, and slowly you can also reverse it back in the other point. So this is called jack screw basically, and these are normally used to convert any rotary motion into linear travel. See, the screw is rotating, okay, but what type of motion it is actually giving you? A straight line motion. The screw is rotating, but the screw is rotating like this, that shaft, right, but it is traveling in forward direction or maybe in the backward direction. This is like a linear direction. It is actually moving in a line. So it may rotate like this, but it is actually giving you a linear motion. So rotary motion is converted into linear motion in case of a jack screw. Okay, they are very coarse thread, not fine thread, coarse thread, because fine thread is not required here. We require coarse thread. Coarse thread is required to take take a huge amount of loads, because these actuators will be going through very drastic changes in the flight situations where the the control surface needs to be moved, and so many things needs to be done. So this is the reason the jack screws have been designed in such a way so that they can take the load. And also it is an ideal thing for trimming purpose. I already told you about trimming in the part 1 video. Trimming is to correct those minor errors that you have in your control surface movement. So let's say 1 degree, 2 degree errors that you have. So in order to bring it back into the perfect position, this type of screw jacks are the best things, because they will be rotating very slowly. So you can get any desired angle, any desired any required point, or any desired angle of your control surface. Fine. Then we have torque tubes. Torque tubes are the ones which actually apply torsional or rotating motion to a member of the control system. Torque tubes are often, we see this type of torque tubes which are used to actually control. See, where is torque tubes diagram? I'll show you. See, this is torque tube. Fine. This is the torque tube. What exactly is the torque tube over here in this diagram? This is the one. Okay, like you have a control linkage mounted like this, which is hinged over here. Now when you push or pull this rod, so this torque tube will also rotate in accordingly, either in clockwise or anti-clockwise direction, and that will further rotate this particular bell crank, or rather which you should call as a quadrant. Okay, there may be something also, something else as well. So torque tube is basically used to transfer the motion. Okay, it is transferring the motion by the help of some torque that is applied on it. Conventional cable and push-pull systems link the flight deck controls with the hydraulic system, and with the system activated, the pilot's movement of a control causes the mechanical linkage to open and close the servo valves, thereby directing hydraulic fluid to and from actuators, which convert hydraulic pressure into the control surface movements. It is very simple, which means any conventional cable or push-pull type systems, if you see, conventional in the sense the ones that have been using for a long time, that we have been using for a long time, it is like any mechanical movement that you are sending from the control column that will go and operate the servo. Servos are very small motors basically that will open some valve. There will be some valve that will either open or close, fine. So through which the hydraulic fluid will pass to those actuators that we have. Okay, that if hydraulic fluid gets inside the cylinder, it will push the actuator. Okay, and if we bring back the hydraulic oil from the other side, then it will pull the shaft inside. So accordingly, this movements of the control cables takes place where there is a mechanical as well as hydraulic systems are incorporated in some aircrafts, which are also called as hydromechanical systems, fine, where mechanical systems also hydraulic systems work together. So there is a risk of overstressing the structure of the aircraft in some cases where, let's say, the pilot is not understanding what amount of load you are actually applying on the aircraft's control surfaces. So designers incorporated artificial field systems for this in order to make the pilot understand what amount of load he is actually applying on the aircraft's control surfaces, so that he do not bang too much, so that he do not hold a particular control column for a long time, which is going to apply a lot of stress on the structure because of the aerodynamic forces taking place on that. So what we do is we use a artificial field system. What is this artificial field system? By the name we can understand, it is a sort of a feeling. It gives you a feeling that to what extent you have moved it. So where it is there, this provides increased resistance to the controls at high speed. When there is a high speed, so the control column lever that we have in the cockpit, okay, so that if you move towards the left or the right or maybe down or backward or forward, whatever the case it is, that will have some sort of a sensation or the feeling in the hands of the pilot, which will not allow him to move it in any direction or immediately whatever is required by him or whatever he thinks is correct. So that will give him some feel like that will increase a lot of load on that particular handle or that bar, control bar, so that he can feel that what amount of force he is actually applying on the control surfaces. Okay. There is a stick shaker also, which provides artificial stall warning to the pilot. Stick shaker and stick pusher, these are the two things which if I am not wrong, there is stick pusher as well. Just a minute. Anyway, it's not given here, but there is something called stick shaker and there is something which is stick pusher. Okay. Stick shaker is something which is used to aware the pilot that there is some stall warning that is going to take place. Anytime the stall can take place. Stall happens when the aircraft reaches its maximum angle of attack. Okay, the wing will reach to a certain angle which is more than 15 degree, and the moment it reaches 16 degree, it is supposed to stall. Okay, we have read this in aerodynamics. So in order to avoid such situations, what will happen, a stick shaker is there. Now what is this stick shaker? It is basically the control column that you have in the cockpit that will be moved artificially by the help of a motor that is connected to it at the bottom inside the cockpit pedestal area. So that will basically move this stick, I mean the control column, that will shake the control column very vibrantly, so that the pilot can understand that there is some problem. Okay, it is to get his attention towards it. Mechanical control network is there in large aircrafts, and as a backup means, in the event of hydraulic system failure or failure of the hydraulic control systems, mechanical systems will be there as a backup. Obviously it has to be there, because there may be chances when the hydraulic system will fail or the electrical system will fail, then who will control it? So there has to be some emergency mechanical systems. Normally multiple computers are incorporated for these electrical and electronic controls, with autopilots, auto landing, auto speed, braking, flaps, stall warning, ground proximity systems and all these things. Autopilot, you know, where you basically set everything you in the flight monitoring system, and then the flight is normally taken by the normally it is flown by the help of that flight monitoring system only, which is also called a flight management system. So that controls all the desired control surfaces and everything as per the required movement. Okay. Auto landing is what? Auto landing is that you don't have to land it, the aircraft will automatically land. Okay, so that's auto landing. In very few aircrafts this is there. Okay, very sophisticated aircrafts which are having such good avionics instruments, only they can land properly. Auto speed braking is there. Whenever there will be a certain speed above which the aircraft is going, it will be the speed braking system will immediately gets activated, so that it do not reach to that a certain higher speed which is not desired for it. Then there are flaps, then stall warnings are there. Ground proximity system. What is this ground proximity? Ground proximity is basically a sensor. The moment you are about to touch down, okay, when the tail surface is just about to hit the ground, so this ground proximity system gives a warning that you have landed, tail is touching the ground or not. Because when the aircraft lands, normally it will be landing on the main wheels, so obviously the tail will be very close to the ground, so that the tail do not touch the the land or the runway. That is the reason ground proximity systems are there. Fine. Electric trim is there, which is often found to control the position of the horizontal stabilizer. Okay, electric trim, it is basically used to control the horizontal stabilizer, that is the elevator, so that the aircraft do not pitch down or flow up, so that the aircraft do not fly up or go down. That is the reason this horizontal stabilizer is used. The switches to operate the trim is located in the control yoke, okay, which is also your joystick basically. Pilots must activate both switches simultaneously to engage the trim motors. Whatever the trimming is required, that will be done by those motors. The mechanism is commonly found on the pedestal. Pedestal area means the instrument section or the units that is in between the two pilots. You must have seen when you get inside the aircraft in the cockpit, you have seen the middle position. This middle position, let's say this is the cockpit, there are two chairs over here, two seats basically, not chairs. Then this middle portion that is there just is a common section for both of them. Over here there are throttles and many other things. This area is called pedestal area. Fine. So that pedestal area and the drives the trim transmission using flexible cables. So mechanism is there, but that will have what? Trim transmission using the flexible cables, which we have already read in the mechanical thing. On many airplanes, the mechanical trim system moves when the horizontal stabilizer is trimmed via the pilot controlled electrical switch, or when the autopilot trims the stabilizer. Okay, what they are saying is the mechanical trim system moves when the horizontal stabilizer is trimmed. Whenever you trim the horizontal stabilizer to adjust your pitching movement, so via the pilot controlled electrical switches, or when the autopilot trims the stabilizer. Fine. So that is a mechanical trim. A horizontal stabilizer trim brake system is there, which is also used to basically like this mechanism arrests the motion of the stabilizer during trimming operation when the movement of the elevator controlled inputted by the pilot opposes the direction of trim. Which means that at any given point, if the pilot is asking for something which is not desired, okay, which is not required at that point of time, let's say I'm just giving you an example. For example, the aircraft is in this condition. For example, the aircraft is in this condition, let's say, okay, and there is this vertical stabilizer here, horizontal stabilizer here. Now if it goes down or it goes up, accordingly the pitching movement will happen. Okay, aircraft will also, the nose will also go down and go up. So for any chance, if the pilot is putting it too much, if he is giving too much of control input to the elevators, okay, and he is trying to quickly descend or maybe quickly climb, so at any given point, if the condition says that such input is harmful for the flight characteristics, I mean for the flight, that the flight may lose its control or anything, in that case this type of trimming systems are incorporated with some control which opposes the direction of the trim. I mean, even if he or she is trimming, even if he or she is putting too much of effort into get a control surface movement, but that will not happen because of this trimming. Okay, it will not allow the pilot to do anything anything he or she wants. Okay, so error can be minimized in this way. In the event of a complete hydraulic failure, what will happen? The crew may operate the flaps using an electric motor. Fine. So that is an alternative mechanism. By the help of electric motor, you can operate the flaps because you need the flaps to actually, uh, control the aircraft when it is landing. Fine. For a proper landing, you have to extend the flaps. So flaps are required definitely. That is the reason. A complete hydraulic failure, whenever it will occur, the alternative is to use an electric motor to control the flaps. Okay, so the next part is pneumatic. Okay, now where is this pneumatic systems are incorporating the aircraft and how they are being used? Fine. So pneumatic is something that is related to air. Anything that you not only air, rather I would say any type of a gas also, that is also part of pneumatic system. So any system that operates by the help of fluid that is gas, like maybe nitrogen, maybe hydrogen, maybe oxygen, it may be air also. Fine, it may be a combination of all the gases like air. So that type of a system will be called as a pneumatic system. Okay, especially when we are using such systems to derive some power, to get some power. So another technique is for assisting in the movement of the control surface of large aircraft. It is called balance panel. Now what is this? It is basically there are two chambers are established in a balance panel, and what happens is that the pressure differential generated by the deflection of the control surface allows the balance panel to assist the movement of the flight control. Control surface is moved from the neutral position, differential pressure builds up across the balance panel, and this differential pressure acts on the balance panel in a direction that assists in the control surface movement. Okay, so it is basically there will be a chamber, there will be two chambers basically, and there will be sort of a diaphragm. So there will be pressure difference between those two chambers. Okay, there will be two chambers and there will be a diaphragm, this one, and there will be pressure difference. If this is pressure is P2, this pressure will be if this pressure is P1, then this will be P2. So due to this pressure difference, what will happen? Obviously, if this pressure is high, then it will allow the diaphragm to like bend in this way, right? So what is happening is that the pressure differential generated by the deflection of the control surface, so this pressure differential will be connected in such a way that the control surface will deflect by the help of this differential pressure, which allows the balance panel to assist in the movement of the flight control. Means you don't have to actually apply too much of effort to move it. Due to the pressure difference in the two chambers, what happens is that the pressure which is at a higher level will be pushing the lower chamber in such a way that will assist the control surface to move forward. Okay, I mean the actuators to move forward so that the control surface can be moved. So when the control surface is moved from the neutral position, differential pressure builds up across the balance panel again, and this differential pressure acts on the balance panel in a direction that assists in the control surface movement, which also means that if you move, let's say it is at a this is, let's say this is a control surface, let's say this is a control surface, this one. Okay, and it is connected in such a way to a chamber, okay, which is having high pressure on one side and low pressure on the other side, that this pressure difference is connected in such a way to this control surface that due to this high pressure the control surface is also getting some assistance in being moved either up or down. Fine. So now when this is at neutral position, the pressure difference is also not pushing it anywhere. It is also at neutral position. But the moment we move the control surface, let's say up or maybe down, fine, or up or down, so that will do what? That will further create some pressure inside that small two chambers, which is holding the pressure inside, and that will further be stored in a form of energy. Okay, that will be stored like in the form of an energy, the movement of that control surface. Okay, so the moment that energy is being stored inside the fluid, in the pressurized fluid, so when you have to move, let's say it has come down some, it has actually acted in an opposite direction, so that's the reason it has compressed or pressurized the vessel, okay, in the opposite direction. Now this pressure over here is having some stored energy because it is compressed in the other direction. So the moment you have to move it again at the top and you have to put it in back to its neutral position, what you require is you just leave it, and this pressure will allow the forward movement, or rather the opposite movement of the flight control surface in the other direction, fine, and it will slowly come and be in the neutral line again. Okay, so it is like stored energy. Now next we will be studying about fly-by-wire controls. Okay, so this is also part of your control systems only. Fly-by-wire control system employs, you know this, like fly-by light and fly-by-wire. Light is it has not been incorporated into aviation so much because fly-by optic is such a thing, or fly-by light or optics, whatever you say, is very costly, first of all. Second of all, fiber optics implementation in aviation requires a lot of, you must have studied this in module 5 also, that requires a lot of cost, as well as maintenance is very difficult, adequate training is not there with many people. Okay, and if not done in a proper way, then what happens is there will be a data loss, right? So that is the reason till now we have not implemented in aviation fly-by optics so much, like in all the aircrafts. There are definitely few in which it has been tested and experimented, and it's used also. But fly-by-wire is something that is mostly used in modern aircrafts now, which means that you get assisted or get helped to control your control surfaces by the help of wire. Wire means you are transferring data through wire over here. Okay, till now we have started from mechanical systems which used to have control systems. What you have read, we have read that there are control cables, there are push-pull rods, there are bell cranks, there are pulleys, there are various other things that was enhanced, and hydraulic actuators were put into it. So that was the second version of it, where the mechanical as well as the hydraulic, both things came into picture, and it became hydromechanical, which is a bit more efficient, okay, to control huge aerodynamic loads. Then now we will be incorporating electronics also in this, so it will be mechanical, it will be hydraulic, as well as electricity will also be there in this. So now you don't have to move anything, it will be like all switch operated things. Okay, you operate the switch, you just trim it, you just move a knob, and that will do all the work. Okay, so system as such has not totally changed, but yes, some enhancements or we should say like some improvement has been done in the systems. Some more components have been involved in the systems, so that it can be made more efficient and with having very less amount of effort that is required by the pilots. Fine. So this employs some electrical signals that are transmitted by the pilot's action from the flight deck or the cockpit through a computer, or through various computers rather, to various flight control actuators. Okay, so okay, so this is basically a component. See over here, you can see everything. Like you can see there is a jack screw which is mechanically moved by the help of an electric trim motor that will trim the mechanical movement, and then there is a mechanical trim over here also. So you can mechanically trim this particular thing by the help of your cables and all. You can electrically trim it by the help of this motor. Fine. And there is the jack screw or the nut that I have already told you what is a jack screw, right? So it is like the actuator piston which moves through a screwing action forward and backward to move the control surfaces. Now okay, this is the balance panel that I have explained to you recently just now. So this is the balance panel. Okay, there is a high pressure area, low pressure area. So from this high pressure area to low pressure area, this diaphragm in between that is there, that I was telling you, this diaphragm in between, these if moves, so that will assist the movement of the control surface. This is the control surface. Okay, it is hinged at this point. It is also hinged with this diaphragm, right? So high pressure area will push this towards the top, and that will further move the control surface. Okay, now let us get back to the fly-by-wire system that we are talking about. See, electronic fly-by-wire control systems can respond to any changing aerodynamic conditions by adjusting the flight control movements. Okay, because this type of systems are also called as your closed loop system. Something is some systems which are mechanical systems or maybe hydromechanical systems which are called open systems. Open systems are the ones which, like, you are giving some input from the flight deck. Okay, the work is being done, and then some output is taking place. But that you cannot see back in the cockpit, right? So this is an open loop, means it starts but it goes straight and it do not come back. Okay, no feedback from the output or no feedback from the particular control surface comes back in the or not. Fine. So in that case, what you have to do is, in that case you require some feedback mechanism which is called as closed system. Why it is closed system? Because whatever the input that you are giving, that will go through some computer, some commands, the mechanical things, the hydraulic things and everything, and finally the output will take place, right? It will position or trim accordingly. Now let's say the control surface has deflected to 3 degrees, 3 degree movement. Now you have also given from here 3 degree movement. Now how will you understand in the cockpit whether it has moved exactly 3 degree or not? So there will be sensors which will return another line to the cockpit, and it will match with the value that you have given and the value that you have got. Okay, it will match whether 3 degree is equal to 3 degree or not. If it is so, then fine, the control surface actuation has been done. So there will be no further movement of all these motors and electrical things over here, right? But let's say this has not reached 3 degree but 2 degrees, which means you have asked for 3 degrees from the cockpit, but it has not moved to 3 degrees, it has moved to 1 degree or 2 degree or maybe 4 degree. It has overshoot. So who will understand this? Those sensors will return the value to the computer, and the computer will understand in the cockpit that the value that I have sent, or rather the value that the pilot has sent, whether it is equal to that value or not. If it is not, then it will again deflect the actuators to get that exact angle that is required. Fine. So this is a good thing about electronic fly-by-wire systems. Okay, it can adjust the flight control at any given point of time, and that is the reason it also is the main reason for making autopilot system. Okay, this is the main thing which helps in making the autopilot system of an aircraft, because automatically they are doing everything, all the adjustments and everything is being done automatically. So the computers can be programmed to prevent any undesirable, that is unrequired, not required, or any dangerous characteristics such as stalling, spinning. These things can be avoided. Okay, just by the help of programming the computers, the computer will take care of the aircraft even if the pilot fails to do it. So these systems rely on the translation of control inputs into electrical signals and the conversion of these electrical signals into control surface movements. So it's a very simple thing. You are giving an electrical signal that is going through some computers, okay, and going into some mechanical movement, or rather some hydraulic movement in the actuator, and further that is coming via some sensor which is also an electrical movement, right? Some electrical value only it is coming to the sensor and straight back to the cockpit again. So now those two electrical values will be matched, and accordingly the movements will be done. So what are the components which are actually required to do it? There are transducers. Transducer is basically a sensor, okay, that senses the movements, the pressure, the temperatures, and so many things. These are called transducers. Why? Because they are transmitting the sensed value or the sensed data. Okay, so they are transmitting. That's the reason they are called transducers. Then you have got rotary variable differential transformers. Rotary variable differential transformer means these are some type of a unit which actually senses what is the rotary motion. Okay, so according to that, these transformers will create some electrical these transformers will, yes, this transformers actually create some electrical output that will further go back to the cockpit, and from there it will be sensed. Okay, electronic display screens are there in the cockpit, we know. There are other sensors also. There is artificial field system that I have already talked about. Power control units are there, which are small hydraulic actuators. Power drive units are there, which are like motors, and you have got other apparatus also which are used for the control operation. Fine. Now there are some enhancements also which has been done in the control surface to reduce or eliminate the fluttering during flight. In the mechanical system, what used to happen, there are a lot of fluttering that used to take place. Fine. So those fluttering has been minimized. Fluttering means it's a abnormal vibration of the control surfaces. Okay, so a lot of sound also produces for that. So it's like a tension always inside the cockpit. What is the sound coming out from and why it is happening? It doesn't give you a good smooth flight also. A lot of drag and problems will be faced. Okay, in Airbus A320 or the family of A320 actually, I mean 319, 321 as well, was the first commercial airliner to use the fly-by-wire controls normally, but as per the requirements, then many modifications were done. Okay, so then Boeing used them in their 777. Then the newer design commercial aircraft that are coming, those are also using it. Like if you say about the global Bombardier global versions, then you talk about the Dassault Falcon 7X was the first divisional jet to use the fly-by-wire control systems. Okay, so any modern aircraft that you see, whether it's a passenger carrier or it's like a private jet, so they are all opting towards fly-by-wire systems. Okay, fly-by optic is what? It is further improve the ability of the system to transfer data through by light, right? By the help of light, it will transfer the data. The speed will be highest because we know that the speed of light is the highest in the universe till now, and transfer data at higher speeds also, and are more immune to electrical interference. More immune means that there will be very less disturbances due to electrical interference, magnetic interference inside the cockpit, because when there will be a lot of units together, no, what happens is one avionics unit gets sometimes clogged or stopped, or it is like its function is retarded due to some other avionics unit, due to the electromagnetic interferences and all these things. So that will not be there in case of fly-by optics or fly-by light system, because light is not immune to light is not having any sort of a distraction due to electromagnetic waves. Okay, fly-by wireless. Now what is this? This is a next generation thing that I mean, questions generally do not come, but if you do fly-by wire, which you are doing now, you can do fly-by wireless also, which will be like remote control things. Everything from the cockpit will be remotely controlled into the things, and all the wires will go away from the aircraft basically. So whatever the cost of wires and the reduction of weight due to due to no wires all total in the aircraft will actually be a beneficiary thing. But it is very important to design those things in a good way, because everything will be monitored wirelessly. You can say just by the help, just like a remote control is used. So in the same way, everything will be controlled from the cockpit by the help of remote control mechanisms inside the aircraft. So that requires a lot of sophistication, obviously. That will reduce the maintenance also, and it saves the maintenance costs over the other over the life of the aircraft. Okay, a lot of maintenance costs will also be saved. Electrical hazards will be less in those cases. Artificial field system I have already discussed. I am telling you one more time. It is a purely mechanical flight control system. Do not require any artificial feel to the controls. Now why? Because any purely mechanical systems like we have in the Cessnas and all those smaller aircrafts, where you know that whatever the movements you are doing, you can actually feel it. Okay, if the loads are high, huge loads that are taking place, generally they do not fly to that high speed, but anyway, but you can still understand like what is the load that your control lever is imposed to, so you can feel it. But the same you cannot feel in the modern systems that we have just read, the electronic systems, the fly-by-wire systems. Over there it's all switch and control mechanism, right? So if you're trimming something, if you're trying to control something, you are just moving a switch. You just can't feel what amount of aerodynamic load can be imposed on the control surface, like let's say radar or maybe the elevator or the ailerons, by that little movement of your switch from the cockpit. Okay, so you have to understand to some extent, isn't it, that what is the extent of that movement. You should not do too much, you should not do it too less. Okay, so that is the reason the control surface, as it is deflected into an airstream, is not directly transmitted to the pilot. What happens is that the manufacturers have developed an artificial field system to provide this feedback regarding the control unit. Okay, so you can feel it when you are putting the trimming switch right side or left side. You can actually feel it. When you trim it too much, you will feel too much of resistance in moving the switch, which means you have moved it too much, right? So that is sort of a feel that you can get in your arms and your fingers while you are moving the switches and the controls. So mechanisms used to produce artificial feel may be mechanical, spring loaded rollers that fits into the valley of a flattened V-shaped cam. This is just a general description, it may be different to different aircraft. Control input is increased and roller rides higher up of the side of the cam, and thereby increasing the spring resistance felt by the pilot. Okay, so there will be many springs and many things which will increase the resistance of the movement of your switches and controls, so that you do not do it too much. Then you have got yaw damper. Now what is yaw damper? See, yaw damper is basically sort of a mechanism that is used to like eliminate one tendency of an aircraft. What is the tendency? The tendency is called Dutch roll. Now what is this? This is basically, see, typically associated with aircraft using swept back wings. Usually we have the modern aircrafts are all swept back wings, right? So when there will be a swept back wing like this, okay, swept back wing that is going backward, so they will generally have a Dutch roll. Dutch roll is what? It is sort of a yawing as well as rolling, both will happen. So the aircraft will be rotating in a like a 8. Okay, aircraft will be rotating like an 8, like this it will rotate. I mean the wings, the sorry, just a minute. Let's say this is the wing of the aircraft and this is the fuselage. So once it will go down and on left side, then after some times it will go down on the right side, then again it will go down on the left, again on the right. So that way it will be just making this type of oscillatory movements, continuously. Okay, at the same time it will also do a snaking movement also through its path. Okay, so two motions. One is your yawing, that is your left and right movement. Whenever you control, you try to actually apply the counter the rolling tendency of the aircraft during the flight. Yaw dampers work when the aircraft is controlled manually by the flight control during operations involving the autopilot. So this provides inputs to the radar in proportion to the yaw rate and negates the oscillation, which means two movements cannot take place at the same time. Whenever you are trying to divert, let's say you have a swept back wing like this and you are trying to divert towards the left or towards the right, whenever you do that, what happens is that creates a sort of if you are banking towards left or you are going towards the left, then this wing will be going down, this wing will go up. Generally if that happens, then what happens is that this side is actually coming more towards the wind then, and it will be pushed again backward side, again in the backward side, so it will again come back to its original position. So what will happen? So aircraft will basically move once towards the left, again when this wing will be hit by air, the aircraft will be put towards the right, again it will come to the left, because you want to go to the left, your radar is moved towards the left, so you will be going towards the left continuously. But this continuous repetition or this frequency of air that is coming and hitting the right side will allow your aircraft to go once towards the left, another right, then again left, then again right. In this way it will do a snaking movement, it will go like a snake. Okay, so along with that the rolling will also happen, what I have showed you just now. So this type of a condition should not take place, otherwise you will lose the control of the aircraft. So in order to dampen that thing, you require the yaw to be dampened and the rolling tendency to be avoided or eliminated. That is the reason some yaw dampers have been put, and they give you a smooth ride. Okay, that gives you a smooth ride of the airplane. Then you have got Mach trim. What is Mach trim? By Mach we know it is the speed of sound, right? 1 Mach means is the speed of sound. When the aircraft passes through the air at speeds around Mach 0.7 and above, which is close to the transonic speed or sonic speed rather, the center of pressure begins to move aft of the wing, right? So when the aircraft reaches its critical Mach number, shock waves may develop over the wing, we know. We have already studied in the first chapters, we have also studied in the aerodynamics that shock waves are created like this when you reach a Mach somewhere around very close to 0.8, 0.9 or maybe around 1. When you reach, these things happen. So when the critical Mach number is reached, certain part of the aircraft will come across these type of shock waves that will cause a lot of resistance and drag. So Mach tuck resulting in a nose down flight attitude. What is a Mach tuck? Mach tuck means that you are stopped by this huge speed, okay, and you suddenly start to decrease the altitude. Okay, when you reach at that type of a condition with shock waves on your wings and the other parts of the aircraft, what happens, you suddenly get a downfall. Your attitude is changed, you get a nose down tendency immediately. So Mach or the speed of sound is not a constant value. Fine, it is not a constant value. The speed of sound varies largely with the changes in the temperature, which means at the ground level we know it is somewhere around international standard atmosphere is 15 degrees Celsius. When you reach at 32,000 feet, it is having some different temperature, let's say minus 40. When you reach even more, 36,800 or maybe at 42,000, you have minus 50, 55, 52, right? So that varies. So definitely if there is such a fluctuation of temperature, then your sound speed will also vary. So there is a factor which is called coffin corner. Coffin corner is basically the aircraft entering the coffin corner or the critical Mach number, where it is very difficult to keep the aircraft stable, which means you reach a particular state where you go and hit the Mach number, that is you go very close to the Mach number, the shock wave is also created, your nose down tendency has happened, so now you are going down like this, your speed is very high, so obviously there will be a tendency of crashing, right? So you will lose control of the aircraft. Equally, just think about it, you cannot decrease the speed immediately. If you decrease the speed immediately, that will also take you down. So neither you can increase the speed nor you can decrease the speed, but you have to be within that phase of the flight where you are being pushed backward by the shock waves and you are still trying to go forward, but neither your speed is increasing nor your speed is decreasing and your height is also decreasing. So that is the reason it is called a coffin corner. Means it is such a type of a corner, such a type of a condition happens where it feels that you are at a dead condition. What do you mean by coffin? Coffin is, we know that the dead people are kept in coffin. So it is a very dangerous condition. It's a very dangerous situation in a flight maneuvering point of view, if you say operational point of view, that the aircraft will enter, the moment the aircraft enters at such a condition, that coffin corner, it is very difficult to keep the aircraft stable. So any reduction of airspeed will cause the plane to stall. Equally, any increase in the airspeed will generate a loss of lift. So you cannot go in either way, neither you can increase the speed nor you can decrease the speed. So pilot will strive in this type of situation. Okay, they will face a lot of problem during when they enter this flight envelope, which is known as coffin corner. So Mach trim basically trims the nose of the aircraft up as Mach tuck begins to act on the aircraft, and most systems of Mach trim are automatic, which means there is an automatic system when the airplanes will typically have redundant Mach trim systems. Now which means there will be more than 2 to 3 Mach trim systems. Now at that type of a situation, when neither you can increase your speed nor you can decrease your speed, you are already stuck somewhere. The pilot is helpless. At that situation, this Mach trim will do what? It will decrease the Mach number, which means it will decrease the speed, not decrease the speed, sorry, it will trim the nose of the aircraft up, which means that at that speed only you will be there, but your nose will go down, because your now general tendency of the Mach coffin corner is to put you down, okay, but you are already losing height with the shock wave on your body. Now if your nose is put up just by maneuvering the elevators to some extent, what will happen, that will basically, sorry, elevator should go up to put your nose up. So what will happen basically, that will not take you to the coffin corner. So whenever the Mach tuck will happen, or that type of situation is just about to come, where you reach the coffin corner situation, the Mach trim will automatically operate. Don't have to operate, pilot need not need to operate this. As per the situation, the computer will automatically operate the Mach trim, and there will be no such hazardous situation which can, or the fatal situation which can take place. Then you have got rudder limiters. Now what is this rudder limiter? Rudder limiter is that airplanes are capable of traveling at high speeds in excess of 350 knots in some cases, right? To combat the need for excess structure, limiting control surface deflection during high speed operation. Means, if you are at very high speed, in part 1 also I have told you this, if you are at very high speed, okay, you should reduce the movement of your control surface. Means, if this is your fuselage, this is your radar, let's say, and you are deflecting into that much angle, during low speed it is okay, because whatever the load that will be imposed on this structure will be less, so you will get a desired movement on the left side, no problem, fine. But at very high speed, when the speed is too much, coming and hitting the surface, and you have deflected it also to a greater extent, so your movement will be very sharp and quick, so that may make you skid or slip in your desired path, and the aircraft may actually lose its altitude, height, or rather the controllability and everything. So at high speeds, the movement should be very less on both the sides, whether it's the ailerons, okay, whether it's the radar, whether it's the elevator, everything. But normally over here we generally want to know about the radar, because we are talking about the radar limiter over here. So this is sort of a limiting device, that is, at low speeds the need for substantial radar travel is required. Means a lot of radar travel, radar movement is required at a greater angle. At high speeds above 250 knots, this effectiveness is so much that such huge extent or movement of radar is not required, okay. So same number of degrees of radar deflection, the load placed on the structure also very much increases if you move it to a greater extent. So to minimize this risk, what we do is, we use a radar limiter which do not allow a certain degree of movement of the radar beyond that limit, okay. Do not allow, or actually it does not give you any sort of a full deflection of the radar. Even if you want to do it, still it will not give you, okay. So that is called radar limiter. So it is a safety equipment basically, sorry, safety device or safety system. At cruise speeds, the radar restricts the radar deflection to only 7 degree left and right with full pedal travel. Even if you push the full pedal, radar pedal, but it will not move the radar to 30 degree. Like in the low speed situation, it will only allow the radar to move at 7 degree, okay, and that is sufficient to take the proper turn. You do not require a 30 degree movement. Then you have got gust lock. Is a method of locking the controls when the aircraft is parked. That is called gust lock, and gust locks may consist of a device that extends from the stationary part of the aircraft, okay, that will basically be that will have a connection with the stationary part of the aircraft, so that the movable part do not move, so it will be fixed with the stationary part somehow, and it is to lock the movement of the flight controls with pins and other devices, fine. It will not allow the controls to move. Why it is used? Typically during cyclones, storms and all these things, when it is parked or mooring has been done, so that the controls do not move and they damage the internal parts. That is the reason the gust locks are given, so that anytime any gust wind comes due to cyclone, storms or anything, the movement of the radar, elevator and ailerons and other control surfaces will not take place. So gust locks will typically include a warning which will say like remove before flight tags. We know generally that those needs to be removed, otherwise you cannot move the flight controls, Okay, so whenever you are putting gust lock, remember that the remove before flight tag should be there. If you release the aircraft with the gust locks or the gust dampers, the problem will be the control surface will not be operative in flight situation. So that will cause a huge impact to the safety. Fine. Now we straight away go to balance and rigging. Over here we can see that anytime repairs of a control surface add weight forward and aft of the hinge center line, and the control surface must be rebalanced and checked for proper balance. Whenever you do some repair, either it will increase the weight or it will decrease the weight, so you require a proper balance, right? You require a proper CG calculation and weight balance and everything. So when aircraft is repainted, then also you require this, because paint, if you repaint it means if you strip the old paint, that will reduce the weight. If you apply a new coat twice or thrice, that will increase the load on the aircraft, that will increase the weight of the aircraft. So you require, after painting, you require balancing to be done. So surfaces must be checked also. Control surfaces should also be checked while balancing. So rebalancing a control surface could include both static and dynamic balancing. Now what is a static balance, what is a dynamic balance? So balance, we understand, balance means it is like on both sides everything is distributed well, then only something can balance, we know, right? Now what is static balance? Static means something which is fixed, firm. So it is a tendency of an object to remain stationary when supported from its own CG. They are called okay. Now there are two ways in which the control surface may be out of balance. Static balance, একটা static balance is, one static balance is under balance, another static balance is over balance. One static balance is under balance, another static balance is over balance. Under balance means the under balance one will go down, downward travel of the trailing edge, means it is not at neutral position, it is drooping. Okay, it will go down. That indicates under balance. This is a DCA question. With a plus sign, you have to indicate this condition, that you have to increase it. The upward movement, that is also a problem, that is over balanced upward movement, so that should be given with a minus sign, that you have to bring it down. So anything that droops down, that falls down, that hangs down is under balanced. It requires plus sign, so that it needs to be raised up. And if there is already a raised up movement of the trailing edge of the control surfaces, then that needs to be balanced with the center line, so that is called overbalance, and these situations are not accepted while you are balancing the aircraft and its control surfaces. So better flight operations are gained by nose heavy static overbalance. You need to have a bit of nose heavy condition. Nose heavy condition will help you to come down easily. Okay, it will not allow you to whenever you increase the speed, it will not immediately change its altitude and go up. So we have to keep in mind that a bit of nose heavy condition is always good. Okay, okay. Okay, this will be there in the structural repair manual. All these works that you have to do will be in the structural repair manual, not in aircraft maintenance manual. It will be in structural repair manuals, because these are all structural things. Dynamic balance is what? This balance condition is a rotating body, that it will be dynamic, means movement. Whenever something is moving, at that time whether it is balanced or not. Let's say you are moving a propeller. If it is not balanced, it will vibrate. So in order to reduce that vibration, you have to dynamically balance the flight control surfaces, and the location of the weights needs to be given in such a way so that they do not flutter. Okay, they do not flutter, they become very stable in flight situation. Rebalancing procedures are what? Control surfaces to be rebalanced should be removed from the aircraft and supported, and from their own points on a suitable stand, jig or fixture. Okay, trim tabs on the surface should be secured in the neutral position. The control surface must be permitted to rotate freely. Use a bubble protector or suitable device to determine the neutral position before continuing the balancing procedure. So use a bubble protector, okay, to actually see what is the angle, what are the angles you should keep it at, what are the neutral positions, and then finally, if that is done, then we can actually say that the balancing procedure can be continued. Okay. rebalancing method is given. From all these things, do not DGCA do not give that much of questions, so there is nothing to study so much from here. Next, we will study about aircraft manufacturers use different materials to balance control surfaces, most of the common being the lead or steel. Remember, the lead wool or steel pieces or steel wool are normally used, okay, to balance the aircraft. Wherever some load needs to be added, they use this. Larger aircraft manufacturers may use depleted uranium because it has a heavier mass than lead. Uranium has more mass, so small volume of uranium can actually be used where bigger amounts of loads are needed to balance the aircraft or the control surface. Specific safety precautions must be observed, as uranium is radioactive. So whenever you use uranium, make it sure, for balancing purposes, make it sure that you wear such protective things which do not affect your body parts. Aircraft rigging, it involves the adjustment and travel of the movable flight control surfaces properly and that are attached to the major aircraft structures like wings and verticals and horizontal stabilizers. Okay. Rigging involves setting the cable tension, also adjusting the levels limited, adjusting the travel limits of flight controls and tabs and setting travel stops. Okay. All these things are also part of the rigging. Rigging of electronic equipment, if used, is also a part of the process sometimes. Stall protection and warning system is what? Stall warning system typically involve multiple computers that monitor the configuration of the aircraft and flight data. A stick shaker that provides a violent stick shaking. So I have already told you previously, stick shaker is the one which is attached to your control yoke, which shakes the control column so that it gives a good warning in advance before a stall to the crew. Also, there is a stick pusher which that applies the nose down input to the elevator in an attempt to avoid the impending stall. If there is already a stall situation that has come up and the flight crew did not understand that or ignored the message or did not read it properly or did not actually understood, so what happens is that will the aircraft go to the stalling condition and will it make a stall and create a huge disaster? No. There is a safety device that is called stick pusher or stick nudger that will allow the stick to go down, means the control to go down, which will allow further the elevator to put the aircraft down. Okay, to put the aircraft down. So that is the reason stick shaker is a warning device and stick pusher is a error limiting or rather error correction device through which you can actually correct the okay. In calculating the potential stall, the computers look at the position of the flaps. What is the position of the flap? What is the position of the slat? The speed brakes, the air speed, the angle of attack, the other parameters, everything it will calculate. Okay, only then it will understand whether it will stall or not, because when the flaps are down, it generally do not stall at 15 to 16 degree. It will be going more like 11, it's 21 to 22 degree or even more than that, but then also it will not stall because the flaps are down, so more camber is increased. But if the flaps are suddenly pulled up, then obviously at 20 degree it is a dangerous thing. Okay, it will be definitely stalling. Stall means the nose will come down immediately. Okay, in a jerk, and the aircraft will lose all its height and everything and it will come down. Angle of attack sensors commonly use a vane on the side of the fuselage that provides data regarding the angle that the aircraft is passing through the atmosphere. Okay, angle of attack sensor will give you the angle at which the angle of attack at which the aircraft is passing. So this is the value, sorry, this is the diagram. Okay, you can see this is the angle of attack indicator on the right side. These sensors are critical to safety, and this device is normally equipped with a heater to prevent the build-up of ice. Ice is not allowed to build up. This warning often an oral warning sound in conjunction with the visual warning light will come. That is, in the cockpit you will understand that there is a oral message, means a sound will come for stalling warning. Also visually also you can see it will come in the cockpit also, in the screens, so that they do not, even if they miss one warning, the other warning is not missed by them. Include the improper position of the flaps or slats, the horizontal stabilizer position, and the extension of speed brakes, the parking brake set, and so on. Such conditions include the improper position of the flaps and slats and horizontal stabilizer position and extension of the speed brakes, the parking brake set, and so on. Okay. Landing configuration warning is provided when the airplane is improperly set up for landing. Landing configuration warning will also come. One common warning occurs when all the members of the landing gear are not locked in the down position and the throttle lever is reduced to a lower power setting. Immediately, as soon as you put the throttle down, or if you slow it down to land, the aircraft, if the aircraft's landing gear are not down and locked, so before that, if you are decreasing your speed below a certain speed, it will give you proper warning of putting down the landing gears and locking them, because it understands that maybe the pilot has not focused in putting the landing gear down before slowing down. Okay, so it considers it in this way, that the aircraft is landing without the landing gears on. Okay, without the landing gears retracted. So it takes the information in that way. That is the reason it always informs the pilot that you have to put the landing gear down the moment you decrease your speed in the throttle. The flaps will go down, flaps are extended, the crew receives an oral and visual warning when the landing configuration is improper. Any given time, if there is a landing information is improper, the crew will also, the crew, whoever is there, they will come to know about the oral as well as visual warning regarding the landing configuration. Okay. So that is all about it. Please go through these questions, and with this we complete this particular thing also. I hope it's a longer video, but nothing can be done. Few things need to be explained in a proper way, I believe. Once you understand something, you can very well remember it for a long time just by revising these books, PDFs that I have given you, underlined ones. Okay, go for quick revisions, read less, but whatever you are reading, that same thing you read again and again, so that that stores in your mind properly. Okay, don't try to read everything all together from all the books. That is not required to really pass the examination. For your knowledge purpose you can definitely do it, but for examination purpose 1 to 2 books or maximum 3 books are sufficient. From where you understand, read it, fine, and I think that will be more than enough for you. Okay, I'll be trying my best to come up with the other modules as immediately as possible. And thank you so much for all your support and everything I can see. And you find any sort of any complaints, problems, or like any suggestions that you want to give me, you can come up. Please feel free to come up. There is no issues. Okay, and I'm just ready to incorporate that into my video series and everything. If that is a better thing, then definitely I'll implement it. No issues in that. Thank you.